This is experiment C9. Today, we are going to investigate the reflection of a ray of light through a transparent block and its reflection at a plane mirror. Students, do take note that before the start of an experiment, always read the procedure at least twice and study the diagram carefully before we proceed on with the experiment. For this experiment, the skill set we are testing is whether you are able to locate the image of the two pins in the glass block and mirror and able to align them in a straight line with the actual pins. What we have here is a mirror, two pins, glass block, and a protractor. The first step is to face the transparent glass block with the larger face down on a sheet of plain paper provided and carefully draw the outline ABCD as shown. The side AD must be along the left edge of the paper. After that, remove the block from the paper and draw the line AE at an angle of 30 degrees to the line AB. Mark a position P1 on the line CD 2 cm away from C, the corner of the glass block. After that, replace the block on the paper and place the mirror along the line AE with its face vertical. This is how the setup looks like. The mirror at an angle of 30 degrees vertical with the glass block at the edge. Place a pin P1 touching the block such that it is 2 cm away from the edge. Observe through side CD of the glass block. This is side CD. The image of P1 produced by the reflection in the mirror. After that, place a second pin such that P1 and this pin P2 and their images lies on a straight line. Mark and label the position of P2. When you look at the side CD, this is how the situation is like. The image of P1 is located inside the glass block and the mirror, as well as the image of P2, and this is the actual P1, this is the actual P2. This is what the final view will look like. P1 and P2 and their images all will lie in a straight line. This is a video to show how to get the pins in a straight line. This is P1 and this is its image. Adjust your eyes to the left and right such that P1 and its image lies in a straight line before inserting P2 as shown. Mark and label the position of P2. P2 should be somewhere along this line. Remove the pins, mirror, and block. Draw the line P1, P2, and mark a position F on the line such that the distance PF equals to 6 cm. If you refer to the diagram, this is how it should look like. This is your P1 marking, this is your F, and they must be 6 cm apart. Measure the perpendicular distance x, as shown in the diagram, between F and the line CD. And if there's a need to extend CD, please draw a line across. Record the angle y and the distance x. We are at step number 11. By altering the angle y, repeat the experiment to obtain at least 6 sets of y and x values using a wide range of y values. Each time the distance PF must be 6 cm. After that, you should plot the graph of y against x, and the graph is a curve. This is how your data should look like. the trend should be decreasing. Read from the graph, alright, for which the value of x is 4 cm. After that, to calculate the gradient, remember to show your gradient triangle, your coordinates in the working, as well as answers to 3SF. And this is the sources of error. Do remember to always state that, alright, the error will affect the reading R.